I would like to invite on stage our next speaker, Joinal Ahmed.
Hi everyone, good morning. Give me some energy. I'm flying since 3 a.m., so I need energy from you to drive the session. Good morning. Good morning. That's great. Hi everyone, thank you for that introduction. I'm Joinal Ahmed. I work as an AI architect at Navatech. It just says AI architect, but I look across cloud and security also. So that's about me. I had worked with Google Cloud and AWS majorly on the same AI and that area. So I'll be sharing some experiences of how I ended up into building all of the ML solutions that I build and architect them more as a serverless fashion. So why to take that decision, and then maybe share my journey with you all. I think just a small introduction. This will help you to understand why we have to go serverless. So we build an AI-powered safety risk management solutions, right? So think about a worker working at a remote location, giving the right information to him about maybe let's say how we should operate some machinery safely and those details, right? That's what we do. So we'll start with I think anyone who has worked on ML projects or tinkered around deploying these models. Any show of hands? Quite a few, right? And you'll understand. I think deploying these machine learning models is hard, right? It's not only because of if we try to map it from, let's say, traditional software engineering, and not say traditional, but software engineering to machine learning. Here the systems are defined by the data, right? It's just a black box. We necessarily don't understand what is going on, right? Everything, the behavior depends on the data that we get in, right? And there are a lot of things that comes with it. Things like different organizations have different ecosystems, or you might have to integrate your models into different kind of applications, right? It can be for example, the Android app versus a backend system that runs on batch processing and whatnot, right? The compute, continuously making sure that you have right amount of this large compute supplied to this model to consume and give the responses, that adds in another layer of complexity, right? With that, portability is a challenge. We all work on our laptops or Jupyter notebooks in general, but how do we then take that notebook, productionize it, deploy it on the cloud or into the edge applications, right? And season related, I think when Prashant was saying, suddenly marketing teams does something, or there's festive season coming in, a lot of traffic will go to those applications that you build, right? So how do you make sure that these models, you still keep on supplying those large amount of compute to them so that it runs as expected, right? And it's just a summary, right? Operationalizing is not trivial, right? There are a lot of hands involved at every places, right? While the business leadership understands the set goals, or they know that I'll be giving you, let's say, X amount of users. Now you need to serve them. There's data engineer involved who will maybe help you with ETL, getting the data, and making sure that your data science or ML engineer have the data to build this model and deploy. At the end, you have IT operations, DevOps, SRE teams to manage the end cycle, right? This talk is majorly for the ML engineers or people who work at the intersection of machine learning and the backend systems that integrate, so that you understand how things are done. We all are familiar with this standard flow, right? We all say machine learning is a sequential process. You start with data ingestion, data cleaning, feature engineering, then you go all the way to deployment. Everyone agrees with me on this? It is more majorly like this, right? There are hidden loops, right? That we don't understand, right? We always say, take a model, deploy, and you are done. But it's actually, you might have to take that deployed model, do monitoring management to figure out if things are working well, and then do a continuous training, or even maybe basis on the metrics that you generate, you can decide, I need to deploy an entire new model, right? So that entire cycle goes again. And if you now look it into different steps, right, this is more like a cyclic way, right? Start with discovery, or figure out what you want to build. Then you maybe do a small POC to figure out what is even if the idea or the solution you're building is feasible or not, right? Can it be even built with the right data that we have? Then you go with feature engineering, building those model, evaluating, and you finally go for deployment it on the environment that you choose. So this is with the entire flow, or this is anyone who does machine learning, someone would come in and say, you need to do MLOps, right, to manage this entire flow. MLOps is now the buzz of the town. Every company or every organization is trying to standardize their operations, right? Essentially, the MLOps stack looks like this. You have a data, you need to do data analysis, experimentation. Then you want a feature stores where you will store these process data, so that your backend teams or your ML engineers can consume this to build models, but at the same time, your front-end applications can consume this real-time data to predict. Then you have an ML pipeline. This is visible? Yeah. So then you have a model registry, then you go for serving. There's a metadata store that helps you to track all of the experiments you've done, all of the models which are developed, the architecture or whatnot, right? And then you have model monitoring here in the corner that will help you to figure out if everything is running well. But any guesses what these white blank boxes are? So these are the services that you fill, right? And I think this is the image from 2021. This is still very crowded, but if I wanted to put actually this updated survey from 2023, but the image was so large, it is so crowded that you cannot even identify a small product, right? So there are a plethora of these products, right? Every cloud company gives you some options, and there are a lot of independent SaaS vendors that give you one or the another product that will help you to achieve only smaller tasks, right? And now imagine this, right? Managing each of the services, taking one specific service for only one part of this entire flow, it is very cumbersome or very tiring for that small ML team or the organization to manage the entire stack, right? And just to compare, if you look at the cost associated with maintaining an MLOps platform, even for one model, right? I think it goes minimum is somewhere around 70,000. It goes up to 200,000, right? That's the cost, and this is just for one model for 1 year, right? The cost can shoot up when your organization grows, when you have to maybe take care of more models, deploy them, right? So this is, and this is just a random, or I'd say some estimation. It's not the exact numbers, right? And this is why I'd say we have to, or we had to move to more of deploying our models in a serverless fashion that we can manage this cost, right? We don't have that much of cash in hand to burn on just for the models. So essentially, serverless MLOps, you take the all best of this MLOps platform. What are things that we need to achieve with the MLOps platform? Subtract the infra from it, right? We provision, we take infra whenever we need, and necessarily don't have that Kubernetes cluster where Kubeflow running always, and the feature store is always there even though I'm using or not. That metadata repository is always there even if I'm using or not, right? So it's loosely coupled serverless services that we use, and make that pipeline so that it gives the same operational effectiveness of an MLOps platform minus the infra, minus the cost that incurs with maintaining or having that platform in place. So this is how it looks, right? This is a very high-level diagram, but essentially every piece that we use, it is either hosted in some serverless tool, right? It can be Lambdas, it can be Cloud Run. Somewhere these small snippets are running, and that creates the entire pipeline, right? Instead of me maybe occupying one instance for each service and deploying them somewhere and then building that MLOps platform to do this, right? So start with maybe there is a feature pipelines where I'm running, Airflow or managed Airflow, which is then basis on that specific steps requirement. I'm launching instance, building that. Once it's over, I'm getting away with that instance, right? At the same time, for training, even for inference pipelines, right? We'll look at some examples where you can deploy these models on and more of this Lambda functions, Cloud Run, and these services, so that you don't incur that cost of having that persistent machine always. And now that we do this, the choice becomes too less, right? It's now less cognitive load on us to decide which one to go for, or what services we use. There still are there are still a lot of services, but I think you can pick and choose which one you need basis on that specific need, basis on that specific use case that you're building, right? For example, these days, all LLM applications use some kind of an vector database. There's Pinecone, there is these databases, right? Then for experiment tracking, you have weights and biases. Hosting these models, you have Hugging Face, and then all of these cloud services provide some storage, some compute solution to you, so that you can then run smoothly. Now that is done, right? Now we understand what is MLOps, what are the pains or costs associated with having an entire MLOps platform in place always, and then what we have from the serverless world to give us that same operational effectiveness, but with less cognitive load, with less costs involved, right? The first is, again, I'll give you examples from both major cloud providers. Frankly, these examples would be from Google Cloud and AWS. I've never worked on Microsoft Azure till now, so I'm not sure of that ecosystem yet, right? Essentially, you can use, everyone heard about Kubeflow, which then moved to became AI platform, which now is called Vertex AI, right? So essentially these Vertex AI pipelines, so if you know Airflow DAGs or directed acyclic graphs, so the same concept, you can now create these Vertex AI pipelines, right? So let's say if you go to this step, right? You need a data ingestion step, which will just take the data from the source and store it somewhere, right? Then data cleaning, feature engineering. So each step you can basically now break the code into smaller chunks and specifically assign the right amount of compute at each step, right? For example, for data ingestion, feature engineering, you don't need a GPU instance, right? Earlier, if you had to do a model training, you take a GPU instance and take it always till the entire life cycle that GPU is available, even though you are using it or not, right? So now what you can do is, maybe for the first 3 steps, you can say, I'll just need a CPU instance which will use these steps. Next, when I train the model and deploy it, I'll use a GPU machine to meet that need, right? So this QR code will take you that entire documentation or blog that helps you to implement this. So maybe I think the deck will be shared later with everyone, right? So you can read and try your hands on into it, right? So essentially, this is what you do, right? This is visible. So you create these steps. So first there is a data create step, and I've removed some part of the code for readability. Otherwise, this will be too long script that will not fit in the slide, right? And you might be scared to go ahead back and try it. So you first create a data create operation. You link it with a Docker instance that has that piece of code, and then you assign what storage to use, what machine to use, and where to run it, right? And you compile everything together into a Vertex AI pipeline, and then just create that pipeline. Now, once this pipeline is created, so once the pipeline is created, it will look like something like this on your Vertex AI console, right? Now, this gives you the flexibility to go into each step, figure out what is happening. Maybe, let's say you are running multiple experiments, right? You don't want to do data preparation always. For every training, you don't want to do data preparation. You can just skip the first part because the data is already prepared, and you can just start the pipeline for model training always, right? So then you save a lot of time, money, resources on the previous step and do your experimentations from there. Then you have, even I've seen a lot of people still build these models with Spark ML model, ML library. So you can then the same Vertex AI pipeline can be used with Dataprop to do the data preparation, then train a model, and then even finally with Vertex AI and Dataprop serverless deploy that Spark ML model so that now your backend applications and all your business applications can now use that. Right. So there's also this QR code that will help you to deep dive into it. Then what you can also do is at the same time you can use Cloud Run to host these smaller models, right? So these smaller models that we have created, you just have to do containerize them, and now you can deploy these. And this is just a pipeline, right? So you use Vertex AI Workbench, which is essentially a Jupyter notebooks, trains the model, stores them in cloud storage. From there, you created a code build pipeline that takes the model registers or creates an endpoint and deploys into Cloud Run. And now from Cloud Run, you can integrate this with all of the services that is supposed to use that model. So a more detailed, right? So this is how, right? So everything is with Vertex AI, where you start with the data. Now you use an auto ML model, or if you want to train that model on your user's phone, and then you can do that using the same pipelines that we have discussed. Then you go ahead with deploying the model and creating an endpoint using a Cloud Run. And so the same example, if you look at from AWS, right? So same, what you can do is you package their entire model into a Lambda service, and the same steps, right? You need to create a container with all of the dependencies, all of your model code, all of business logics into that, package them with a Docker container, and now deploy it into a Lambda function. So recently, I think last year is when the timeout limits and the memory and compute of Lambda was increased, right? I think that enables now you to host these larger models which have more memory requirement, runs for a longer time, each invocation takes longer time. So now with that, you can also deploy these models into a Lambda function, right? Essentially, this is what we are doing right now. We create this fast API based application for our Q&A bots, right, which now leverages other LLMs and vector databases like Pinecone, package them together into a fast API service, then deploy it on Lambda. And now this Lambda is called from our web application, all our client apps that can now call this model, right? So yes, there are cold start times, let's say in early morning when we are just getting new users, there's some additional time, but with provision concurrency and a lot of these things, we can also cut down this cold start into minimal, so that the users face for first, let's say, few messages, there will be some additional time, but as your system warms up, as your users come into using that application, you'll see a very minimal latencies for your API calls. Same way, so what you do is, again, I've removed some part of the code, so you load that model into the Lambda handler, where you write the logic of how that model needs to be called, how the data needs to be transformed, and whenever you're getting that event, you process it and send the response back. Essentially, I think this is the last slide. So what you do is same, right? If you now have to orchestrate the same workflow with SageMaker. So SageMaker recently also announced serverless inference endpoints, right? So essentially it uses the same logic where your model function, your web server that is running or that is orchestrating the model, you package them into a container, and then deploy it on SageMaker as a serverless endpoint. Right? Now, SageMaker takes care of automatically scaling that, the infra part, provisioning them whenever your users request for it, and then you host it behind an API gateway so that your applications can connect to that API gateway, and then API gateway orchestrates which endpoint this needs to be called, get the response, and send it back. With me till here. Yeah. So just to summarize, what it gives is, we all know, right? And this is the same benefits that we get from building any application serverless, right? You get scalability because now you don't have to provision, manage those resources. You go cost efficiency because you only pay for what you use, right? You only pay for the amount of time each of the services or each of the instances are used, instead of hosting that entire Kubernetes cluster where your Kubeflow or these MLOps platform is running, right? So you reduce overhead of maintenance. Then, since these are managed services, you also don't have to make sure of maintaining or give efforts on maintaining them, that the services receive automatic updates, right? And then at the same time, it gives you improved availability because now you don't have to take care of scaling your infra, and it can easily integrate. And since these are Dockerized containers, you are not also having vendor locking in, right? You can move from one cloud to another whenever you feel so. And last, right, it gives near real-time inference for all of the workloads that you run with minimal compute assigned. I think that is it. That is all that I had. Any questions? I think we have around 6-7 minutes here. No? Yeah.
So as we all know that, like MLOps is a huge, huge infrastructure service that basically handle for different level models as the pipeline, right? But in a part of the, let's say, I'm just preparing my data set, right? And my data set is unstructured, and I want to store that on the feature store. So which kind of services you are recommending for that?
I think for ETL of the services, right? When you have data at different sources, you want to take or bring them into one place, process them, and store it in a feature service, right? Essentially, what I recommend everyone using Airflow, majorly of the DAGs, right? So you can orchestrate each steps basis on the amount of compute that each steps needs. You can configure when this DAG should run, when this pipeline should run periodically, or based on a trigger which is coming in. And all of these cloud services provides some or the other flavor of Airflow at every day. I think it's AWS, it's called Managed Airflow. Google, it's called Cloud Composer, right? So you still don't have to do a lot of re-engineering if you have moved from one to another, but at the same time, it gives you all of the goodness that things like custom compute assigned to each of these, running them on schedules or based on triggers and all of that.
Okay. And the second question I have is, basically I'm working for the large language model as a part of the large language model team. It's ideal on our WhatsApp. So basically I have a question that is how much large language model deployment? So there is another term very famous is MLOps, right? Large language model operations. So how these LLM pipeline is basically differ from these, or have you ever had any picture on that? Especially?
Yes, right. What we are calling right now MLOps is just blown up MLOps platforms, right? Only because these LLM models are so large in size that the underlying compute or underlying infra is very large. As a typical pattern that what I see on whatever we have also developed is that deploy that ML or LLM separately as a persistent endpoint, because the same LLM will be used at various applications, right? It's just not you are using it only once. So deploy it separately and then build business logics on top of Cloud Run or Lambda, where let's say one application which is just calling that LLM for getting some response, right? There's one other application that is rewriting some of these applications. So all of these business logic are running separately on different Lambda functions, and internally these call these LLM models to get the response, right? To kickstart, you can just integrate OpenAI's model and directly use it from there. And all of the applications that we have built so far, we started with the same way, right? In that same Lambda function, we are calling OpenAI model to get the response, and then rewriting that response basis on our business logic and sending it in on that Lambda's response.
Okay. So my question is around that is like recently I am trying to access that Palm 2 API, right, which is from the Google backend Google card. So when I try to access that, I got access, and then after I want to deploy that with at the same state, like how it's performing when we need to retrain our kind of that, right? So same purpose I'm facing some issues to just track the performance, right? Because ultimately we are using the MLOps to tracking the performance of each and every model and comparing that, and based on that we can deploy, right? So this is a basic simple CHCD cycle. So on that time, tracking the basic metrics, right? Like the RUX scope is that. Then there are other metrics where we are using for tax analysis, right? So constantly training is get a lot of time.
Yes.
Right? So is there anything in Vertex that we can directly monitor for this large language model?
Till now, what I've seen, 𝐶𝐞𝐭'𝐬 doesn't give out-of-the-box tracking or tracing for these models. So, which is where there are tools like weights and biases, 𝐿angSmith, if you have tried, right? So you can now log every request that is coming to that LLM, the response it is generating, and basis on that now you can create custom metrics, right? And then use them to figure out how good this LLM is working, and then retrain the cycle. Right now, as far as I know, 𝐷𝐶𝐬 doesn't provide tracing for these models, but I'm sure they'll be building something around it, and it will be coming soon.
Okay, thank you.
Yeah. Anything else? Yeah.
Thank you for appreciate for your session. So I have a question on the data thing. So in MLOps, data is the important part. So to clean the data cleaning, so what strategy we can use to clean and to identify it?
I think that's a major misconception is that data is part of MLOps, so which is where you have a separate, and then this is people figure out this later, right? That you need to build your data solution first. Things like either you build a data platform, or a lake house where you store the historical and recent data, right? So you need to figure out that part first. That how are you going to capture the data? How do you store it? You have to create multiple views on top of the basis on, the ML team is not only going to consume the data, right? You have business users, you have a lot of other applications that is going to consume the data. So build an data strategy first where you figure out how will you manage and process this data. And then your MLOps platform or ML team is just a consumer on top of that, right? It just consumes the data from the data platform and builds the model or uses the data for like live predictions or this, right?
And is there any tool we can use for the data processing?
Sorry, is there any?
Is there any tool or techniques?
There are a lot of there are a lot of these tools, right? You can, and then this you have to orchestrate basis on how what kind of a data platform you want to build it. You just want to build an ETL logic, you can do it on top of, let's say, this currently whatever DB you are using on top of Airflow. But if you want something more sophisticated where you have data quality control, access, all of this, you might have to move to data warehouse or a data lake platform.
Thank you.
Okay. I think we are on time, so just thank you everyone. Yeah.